Hello, I'm Prabhudas. I'm going to teach refraction of light through a glass slab. This is a glass slab, rectangular glass slab. This has length, breadth, width and thickness. It also has, this glass slab has thickness, length, breadth and thickness. Uh, when light passes through this glass slab, what is going to happen? When light incidents on this glass slab, what is going to happen? That is what we are going to study. This is a rectangular glass slab. This is the view that I have drawn. This is the view that I have drawn, this view. Light falls on this surface. This is a surface. This is another surface. One is the top one and the other one is down one. When light falls on this surface, how it passes through this glass slab is that we are going to study. When any light ray incidents on this glass slab, this light ray is called incident ray. This light ray is called incident ray. The point where the light ray incidents on the glass slab, that point is called point of incidency. That point is called point of incidency. At that point, we are going to draw a normal. Normal is a perpendicular line drawn to a surface. The angle between this incident ray and normal is called angle of incidency. The angle between the perpendicular ray, and the incident ray, that is normal and the incident ray, that is called angle of incidency. This ray is supposed to go like this in this direction in the absence of the glass slab. As light travels in straight line, this ray is supposed to go in this straight line. This ray is supposed to go in this straight line. But due to second medium present here, glass medium present here, the light will not go in this direction. The direction of the light changes due to the change in velocity of light. This is air. When light goes from air to glass, due to the molecular arrangement, where in air the molecules are quite far from each other and in the glass the molecules are quite close to each other, the velocity of the light changes. The change in velocity of light when it goes from one medium to another medium is called refraction of light. As the change in velocity, the direction of the light changes. The light, it is supposed to go in this direction, it bends and goes. This bending of light when it goes from one medium to another medium is called refraction of light. This bending of light when it is going from one medium to another medium. The light is going from air to glass. This bending of light when it is going from one medium to another medium is called refraction of light. As long as the light goes in the glass, it travels with same velocity and it goes in a straight line. Again at this point, the velocity of the light changes. This ray is called refracted ray. This ray in the second medium, this is called refracted ray. And the angle between the normal and the refracted ray is called angle of refraction. When light goes from rarer medium air to glass, it bends towards the normal. It bends towards the normal. Now again here, the light, it has to change its velocity when it is going from glass to air. At this point, change in medium takes place and at that point we are going to draw another normal. Normal is a perpendicular line drawn to a surface. Now if you see, these two lines are appearing parallel to each other. According to the properties of parallel lines, this angle and this angle are opposite angles. This is also R. Opposite angles are equal. If this is R, this is also R. Now this light ray is supposed to go in this straight line. But as there is change in velocity, again it is coming back to air. Again it is coming back to air. If there is change in velocity, again it bends away from the normal and goes. It bends away from the normal. Previously, when it travels from air to glass, it bends towards the normal. Now it is going from glass to air, it bends away from the normal. This ray has emerged out of the glass slab, this and that, this from this surface of the glass slab. This ray is called emergent ray. Emergent ray. The angle between this emergent ray and this normal is called angle of emergency. And this is incident ray produced. This is incident ray produced. The perpendicular distance between this incident ray and normal, this is called lateral displacement or lateral shift. Lateral displacement or lateral shift. This perpendicular distance between the incident ray produced and the emergent ray is called lateral displacement. This lateral displacement depends upon few factors. Angle of incidency, second one is refractive index of the glass slab, the third one is thickness of the glass slab, and the fourth one is wavelength of the light used. Wavelength of the incident light. These are the four factors on which this lateral displacement is going to depend. Greater the angle of incidency, greater the lateral shift is going to be. Greater the refractive index of the glass slab, greater the shift is going to be. Lesser the refractive index of the glass slab, lesser the shift is going to be. Greater the thickness of the glass slab, greater the shift is going to be. Greater the lateral displacement is going to be. Greater the wavelength of the light used, lesser the lateral displacement is going to be. These are the factors on which the lateral displacement or lateral shift is going to depend upon. This is the incident ray. This angle is the angle of incidency. It is supposed to travel in this direction, that is incident ray produced, but it will bend and go due to change in medium, and it goes like this. It emerges out of the glass slab, that is angle of emergency. This is angle of incidency. This is angle of refraction. This is also angle of refraction. This is how lateral displacement is going to be affected as a result of these four factors: angle of incidency, angle of refractive index of the glass slab, thickness of the glass slab, and wavelength of the incident light used. Thank you.